by concave mirror. Okay. So we'll see how the images are formed using concave mirror and other mirrors. Okay. Okay, welcome Abhigya, welcome Aryan, Drishti, and Shayan.
Good evening, sir.
Yeah, good evening. So can we start now? I hope all of you have your, see, before studying this ray diagrams, I expect you, maybe today you do not have, but from whatever class runs, you should have your pen, pencil, scale, compass, all these things should be there with you. If you do not have it with you, I give you 2 minutes. If you can arrange that, if you can arrange that wherever you have kept in your home, so if you can take your all the geometry box.
Sir, 1 minute, I'll come, sir.
Yeah. So everyone, please have your geometry boxes with compass, scale, pencil, everything should be there. Then only you will be able to clarify all everything. Okay, I think everyone is ready.
Yes, sir.
Okay. So see, first of all, we'll be making a concave mirror. So as we know that in concave mirror, the outer side is polished and inner side is unpolished. So inner side is the shiny surface. So this is how some a concave mirror looks like. Okay. So where you will be having your center of curvature, you can say that this is your center of curvature. Okay. So you have center of curvature C. The center of this would be called as pole. And if we draw a line passing through center of curvature and pole, so this line we will call as principal axis. So this line can extend both sides. You can extend this line both sides like this. So this point we call as the pole. Now, if you polish it, so let's try to polish the outer surface. So here you have a little bit of polishing. That is, this is a concave mirror. Now, to study any image, to study how the image is formed, there are a number of light rays, infinite light rays, which are emerging from an object. So if you keep an object at any point, so if you keep your object at any point, that will be that object will from the object a number of light rays will come. But to study the ray diagram, we need minimum of 2 light rays. So here we will try to draw 2 light rays. So see how you will be drawing. First of all, the way I use the compass, the same way you have to do. Use your compass to make the concave mirror. Wherever you place the compass, let that point be the center of curvature and the middle of the mirror to be the pole. Also, suppose if you expanded the compass to 5 centimeters, so take the point 2.5 centimeter to be the focus. At this 2.5 centimeter, mark your focus. Okay. Now, see the rules that we use. the very first rule is that if a ray of light is incident on the mirror parallel to the principal axis. So here you have a ray of light incident on the mirror, and this ray of light is parallel to the principal axis. So this ray of light is parallel to the principal axis. Now on reflection from the mirror, it will pass through the focus. So this is a very first thing that you should remember. A ray of light which is parallel to the principal axis will pass through the focus. Okay. So this is a very first rule. Then we will see some other rule. The second rule states that if a ray of light passes through if a ray of light passes through the center of curvature, so that ray of light, it bends, it reflects back along the same direction. Okay. So why it reflect back along the same direction, that also we will see. So have all of you drawn this diagram?
So
Yes, sir.
Okay. So let's see the second diagram here. So again, we have the concave mirror. Again, we mark this point as the center of curvature. This being the center of curvature. Make your pole. Join this. And mark the focus exactly in between the pole and principal pole and center of curvature. This is pole. Now, the second rule, as of the second rule, we state that if a ray of light passes through the center of curvature, so if you have a ray of light passing through center of curvature like this, so it will be reflected back along the same direction. Just let me have something. Okay. So here you have a ray of light passing through the center of curvature. So this ray of light will get reflected back along the same direction. So it comes like this, and after reflection, it will pass back also along the same direction. So these are the two important rules which we will be using to draw all the ray diagrams. Here we have used the rule that if a ray of light is parallel to the principal axis, it will pass through the focus. Its converse can also be used. Converse means something like this. If you use its converse, so its converse states like this, that if you have a
Good
ray of
evening,
light.
sir.
Yeah, good evening, Shubhans. Any doubts, Shubhans?
No, sir.
Okay. So see, Shubhans, where will this light ray go? If this light ray passes through focus and is incident on the mirror, so where should it go?
Sir, it will go parallel to the principal axis.
Yeah, it will become parallel to the principal axis. After reflection, the light ray will become parallel to the principal axis. So using this knowledge of the ray diagram, we will be making the ray diagram. So first of all, we keep the object at infinity. The infinity means very big. Okay. So we keep the object at infinity, and let's see how it happens. Okay. So if you people can draw the diagram for object at infinity. So mark the points C, F, and P. Center of curvature, focus, and pole. Now, if your object is at infinity, so all the light rays will come parallel to from infinity. Now, whenever if an object is very far off, or if the light rays come from a very far off point, then they come parallel to each other. Okay. So here, if the object is situated at infinity, So all the light rays, they will come parallel to the principal axis. Now, there are two diagrams, but the simplest one is that you assume the object to be very perpendicular and you take two light rays coming from infinity. So you take a light ray coming from infinity like this, another light ray coming from infinity, and since both the light rays, they are parallel to each other, they are parallel to principal axis, so the light rays must pass through focus. So after reflection, they should pass through focus. We observe that the light rays are actually meeting at focus. So are the light rays meeting at focus?
Yes, sir.
Yes.
Yes, sir.
So this was the case when we placed the object at infinity. So here we had placed object at infinity. It was very far off. So infinity means very far off. Very far means suppose the radius of curvature of your mirror is about 10 centimeter, 15 centimeter or 30 centimeter or let's say 1 meter. But the object is situated at 100 meter, 50 meter. So that would be an infinite distance for this case. Okay. So you will get here, and so what qualities of the image or what characteristics of the image are expected? Okay, see. So now you have to write down here image characteristic. In the image characteristics, we will be writing 3 points. First of all, we will discuss about the nature. So what can you say about the nature of the image? Yes? Aryan? Aryan, Aman,
Yes, sir.
Subhash? Yes, all your cameras are went off. Why?
Sir, the image is real and inverted.
Yeah, in the nature, we will write its nature, that whether it's real or virtual. So that it is real and inverted. Okay. Nature is real and inverted. Then the second point we'll write about its position. So where is it formed? Yes. What is the position of image? Drishti?
Uh,
Dhriti?
in front of
Dhriti? Where will the image be formed?
Sir, at focus.
At focus. So image, it is formed at focus. So that image is formed at F. Then what about the size? Meher, what about the size?
Sir, I don't.
Don't know. Okay, so image formed will be highly diminished. Image formed is highly diminished. Highly diminished means it will be very small. Very small means suppose you have a tree whose height is about 10 meter. So you will be getting its image which will be nearly about 2 centimeter or 3 centimeter. So you will get the image to be highly diminished. That means a very small image will be formed at focus. Okay. So these are the characteristics and the ray diagram for the object situated at infinity. Now, if you bring the object, if you bring the object slightly, if you bring the object slightly towards the mirror, if you decrease the distance, bring the object slightly towards the mirror, but the distance as it comes towards the mirror, it's still not at C. It is at a finite distance from the mirror, but it is not at C. Okay, so we call that distance to be beyond C. So this was the first case when we placed the object at infinity. The second case, we draw the diagram for object at The second one is object at, or we have object beyond 2F, beyond C. We have object beyond C. So let us see, let us draw the diagram. So all of you draw your mirrors. I'll just be checking all your diagrams. Okay, so just within 2 minutes, I will check what all diagrams you have made. So do not think, just keep on, just make your diagram. So this is your concave mirror. So see, mark the point C, F and P. If you are using your scale, so use your scale to get the proper points. Now, your object. To understand the object, we take a vertical object. We take a vertical arrow pointing upward. So this is placed beyond C. You place this beyond C. That means a little bit before C you have to place at a finite distance before C. Now again we have to choose the two light rays which we can consider for the image formation. So for the light rays, again one of the light ray we can choose to be parallel to the principal axis. And see, the light ray which passes parallel to the principal axis, after reflection, this light ray will pass through the focus. So the light ray will pass through the focus. The second one, for the second one, you have two options. Either you can choose a light ray passing through focus, or you can choose a light ray passing through the center of curvature. So both you can choose. Either you can choose like this, passing through focus and becoming parallel to the principal axis after reflection, or the other way, you can choose the second light ray to be passing through the center of curvature. See, the ray of light is passing through center of curvature and getting reflected back along the same direction. So it reflects back along the same direction. Abhigya Jain, Aryan, Abhinav, Dhriti. Should I keep on reminding to all of you? Dhriti, are you there?
Yes, sir.
So your camera is not on. See, what happens, I generally uh, follow a few things. Sudhanshu, I will remind you once or twice. From next time, I will just message in the group. Okay, so I'll message in the group that yes, you have not joined, or your camera is not on. So do not do such things. Keep your camera on. If you have to go somewhere, you have to eat, drink, or whatever some emergency is there. So do inform and you can. Okay. So see, now in this case, we observe that the two reflected light rays, they are meeting at a common point after reflection. They are actually meeting at a common point after reflection. See, the point where they meet after reflection, they meet at this point. The point where they meet, that is the same point from where they started. So they started from the tip of the arrow. So at this point, we will get the tip of arrow. The base point will be on the principal axis. So see, if I make this AB as the object, so image would be somewhere, I mark it as A dash B dash. So everyone is able to do the diagram? Have you drawn the diagrams in your
Yes, sir.
notebooks?
Sir, just a minute. So
Okay. So what characteristics of the image do we get from here?
It is real and inverted.
Okay, so we observe here that the image is real and inverted. Okay, this is nature. And what about the position? Where is it formed?
Between C and F.
Between C and F.
Yeah, it is formed between C and F. So see, if you use your scale and compass, so you will always get your image at the correct position. Okay, and the third one is about size. So what about its size?
It is a bit diminished.
A bit diminished. So we will just write diminished. Okay, so it is diminished. So these are the image characteristics when the object is located beyond C. Okay, so in 1 minute, I would like to. Okay, not now. I have still 5-10 minutes. So after 5-10 minutes, I'll be checking all your ray diagrams. Just make sure that your all the ray diagrams are ready. The next diagram we will be drawing by placing the object at C. So see, this is a little bit difficult diagram. Difficult in the sense that most of the time you will not be getting the correct image. First of all, we'll draw it properly, and then I will tell you some other method. So you have the object at C. Now place your object at C and see where the image will be formed. Again, use the same 3 light rays. So let's see. So you have the center of curvature, pole, and focus. Okay. Now you have to keep the object at C. The object should be placed at C. So mark your object at C. Dhriti, are you able to draw?
Yes, sir.
Okay. So I'll be just checking everyone. So from here, you'll take a light ray
One
parallel
doubt,
to
sir.
the. Yes.
Sir, how do you know that it is diminished or this enlarged, sir?
Okay. See, if you observe over here, you observe the size of object and size of image by your
Yes.
observation.
Sir,
So
it
this
is
is the,
quite small, sir. Image is very
yeah,
small.
yeah, it is quite small, so it is diminished. Here it is highly diminished. It's very small.
So, sir, in object at infinity, nothing could be seen, sir.
No, it could be seen, but it's very small. I told you that here, if you have the object of, let's say, a 20 meter, okay. Suppose in this case, the height of the object is about 20 meter height of object. So height of image here, what you will see, maybe around 2 centimeter, 3 centimeter.
Yes, sir.
Okay, so getting 20-meter high object to be 2 centimeter, isn't it highly diminished?
Yes, sir.
Yes. So this is highly diminished in this case.
Yes, sir.
Okay. In this case, you will be getting a smaller object as compared with the as compared with the object, the image will be small. So you can see the height of the image is smaller than the object.
Yes, sir.
Okay.
And one
Now
more doubt,
for
sir. How will we
yes.
know it is real, sir, or in virtual?
Okay. Okay. See, the light ray are actually meeting.
Yes, sir.
If the light ray are actually meeting, then the image is real.
Yes, sir.
If the light ray are not meeting, then the
Yeah,
image is
well,
virtual.
okay, sir.
Okay. If they just appear to meet, they are not meeting, but they appear to meet, then it will be a virtual image.
Yes, sir.
Okay. So these are all real images. Now, when you place the object at C, now draw the ray of light parallel to the principal axis. The second ray of light passing through focus. That means the reflected ray passing through focus. Now you can take the other ray. The second ray can be taken to be passing through focus, so that after reflection it becomes parallel to the principal axis. So you will see the two light rays, they intersect exactly below C. The two light rays, they will be intersecting exactly below C. So here in this case, the image will be formed exactly before C. So you will be getting this exact diagram. You will get this diagram to be exact. Once, what all things should you keep in mind while drawing this diagram? First of all, take the center of curvature to be the point where you placed the compass. Okay, take the point P, which is the center of the mirror, and focus should be between pole and center of curvature. It should be exactly between pole and center of curvature. So you will observe that after reflection, the light rays, they actually meet at a point exactly below the center of curvature. Okay, so how many of you are not getting it exactly below C? You are getting a little bit before or a little bit after C.
Sir, I was getting it, but I have corrected it.
Okay.
Sir,
Anyone
I
else?
currently don't have scale and compass, but I got near C. I don't have scale and compass right now. I will get it below C when I have scale and compass.
Yeah, use, that is why I told you that use your scale and compass. Okay. So from next class, do have your scale and compass.
Sir, the
You will get,
same. Sir, the same issue is with me. Actually, I'm also not having compass right now. I'm getting the object near C. So when I will get it, then I
okay,
will.
yeah, you use everything and then see. Okay, now there is
Sir, one
one
doubt,
trick
sir.
over it.
Sir, I'm
Yes,
getting the
Sir,
object right here.
we need compass, sir, for this.
yeah, you need compass to draw a proper mirror.
Sir, I'm
Okay, sir.
getting it right here.
Yeah, Subhansh, yeah, you are right, Subhansh.
Okay, sir.
Okay, now see, there is a trick to this. Okay, see, in exams, sometimes even by using your scale and compass, you might find it difficult. Okay, so there is a trick to it. Either you use the second method that we call as the cheat method. Okay, so first of all, we'll write the characteristics, then I will tell you the other method which can be used to draw this diagram. So let us write down the image characteristics.
It will be real and
Real
inverted.
and inverted, and it will be formed just below C.
Yeah, formed at C. We say if image is formed at C.
It will be of the same size as the original image.
Okay, so you have Nature is real and inverted. Then you have position, which it says formed at C. Formed at C. And then size. So size is, what about size?
Same size. Same size.
Same
Yeah, it
size.
is same size as the object. It is same size as the object. So image is real and inverted. It is formed at C. It is same size as the object. Right? So these are the characteristics of the image which is formed. Now, if you are not comfortable with this, you will ask in the next class. So that means tomorrow I will be telling you how to draw the same diagram by some other method. Okay. So if you are facing some issue, so the second thing that you can do here only I'm telling you, you can use that instead of using this light ray passing through focus. Okay. You can use another light ray passing through the pole. You can draw a light ray passing through pole. Okay. So if you draw a light ray passing through pole, and so this will be your angle of incidence. At this point, it becomes your angle of incidence I. And at the same angle, you draw your reflected ray. So you will get your image formed at the same point. Okay. So, but this you will be using, if you do not get, if you are finding any problem by using these two rays, so then you should use the third one. Okay. So like you are getting somewhere before C, after C. So use your scale, and instead of using the second light ray passing through focus, you can use the light ray passing through the pole. Okay. So you will be getting the exact one. Okay. The next one, now we place the object between F and C. So the next diagram, we place object between F and C.
Sir, could you once show the previous diagram, sir?
Yeah, sure. Object between F and C. Okay, so this is your previous diagram.
Okay, sir.
So object between F and C. Now you will draw the same mirror, but keeping the object between F and C. Okay, so again you have center of curvature, pole, right on focus. So see, you should use, you can use your ruler. Okay, when you draw your diagram. So in that case, use your ruler over here. See the distance between pole and center of curvature. And at exactly midway, plot your focus. You have to plot your focus in the exactly midway. So now keep the object between C and F, anywhere between C and F. See, your object should be perpendicular. All the objects should be perpendicular to each other, perpendicular to the principal axis. So take the light ray parallel to the principal axis. After reflection, it will pass through focus. Take the second light ray passing through focus. And after reflection, the ray of light becomes parallel. So you observe the two light rays meeting each other. Okay. So do the two light rays meet each other?
Yes, sir.
Yes, sir.
Yes. Okay. So what type of image is formed? Real or virtual?
Sir, real and inverted.
Real. Okay, so again you have real and inverted image. If you draw it, it will be here
Sir, it will be beyond C.
beyond C. This is your AB. This is your A dash, B dash. And writing your image characteristics. So for every diagram, you must write your image characteristics. Image characteristics, they are, it is real and inverted. Then position, where it is formed.
It is
How
found
can you
beyond C.
Beyond C.
beyond C? And size
Larger than the original.
object. Yeah, we can write it larger than the object or we can write it enlarged. Okay. So image is enlarged or larger than the object. So this is the characteristics of the image found by the plane mirrors. Okay. Okay, students. So we have done today these ray diagrams. We are left with two more cases of the concave mirror. We are left with two more cases. One, the object placed at F. The other one, object placed between F and P. So try to draw the diagram. If you are not able to draw, but that is a homework. So I'm mentioning this in the same. Your homework is draw the ray diagram for the object placed at F and between F and P. Okay, but use your scale pencil, everything. For object placed at F and between F and P. Okay, so these are the two cases of ray diagram that you have to draw. Okay, so bye everyone. I hope, do you have any doubts?
No, sir.
Okay, okay, so bye everyone.
Bye, sir.
Bye.
Nice.
Bye. Mhm. Mhm.
Thank you, sir. Bye, sir.
Yeah.